So let's have a look at a functions and graphs question with differentiation from the Leaving Cert Ordinary Level 2012 paper 1. So it's question 6. The diagram shows the graph for cubic function f defined for x as a real number as f of x is equal to x cubed minus x squared minus x plus 6. And we're asked to find the coordinates of the point at which f cuts the y-axis. So we can see that point here. It looks to be halfway between 4 and 8. So it looks like it's the point 0, 6. But we want to find it algebraically. We know that the x value of every point on the y-axis is 0. And so if we take the function and sub in a value of x equal to 0, we get 0 cubed minus 0 squared minus 0 plus 6, which gives us 6, which tells us that when x is equal to 0, y is equal to 6. So 0, 6 is the point on the curve that cuts the y-axis. The B part of the question tells us that f has a minimum turning point at 1, 5, and we want to find the coordinates of the maximum turning point. So we can see the minimum turning point here, and we're told that that's 1, 5, and we're interested in finding the maximum turning point here. Maximum and minimum points occur on the curves where the slope of tangents to that curve would be equal to 0. So we can see that the tangent to the curve at the point 1, 5 has a slope of 0, and so will the tangent to the curve at the maximum point. To find the slope or rate of change of a function, we differentiate that function, and then we're going to let it equal to 0 because we're interested in the slopes at the maximum and the minimum points. So our function is x cubed minus x squared minus x plus 6. So f prime x, the derivative of x, will be 3x squared, the power 3 comes down the front, and the power reduces by 1, minus 2x, again the power 2 comes down the front, and the power reduces by 1, minus the derivative of x is just minus 1, and the derivative of a constant, 6, is equal to 0. So f prime x equals 3x squared minus 2x minus 1, and this represents the slope of our function. A curve has infinite tangents with infinite slopes, but we're interested in the two x values when the slope is equal to 0. So we're going to take 3x squared minus 2x minus 1 and let it equal to 0. To solve the quadratic equation, we're going to factorize. So 3x by x is 3x squared, plus 1 times minus 1 is minus 1, and the sum of 1x minus 3x is minus 2x. And so this is the factorization of our quadratic. We're going to let each bracket equal 0. So 3x plus 1 is equal to 0. We're going to subtract 1 from both sides to get 3x equals minus 1. And we'll divide both sides by 3 to get x is equal to minus 1 over 3. We let x minus 1 equal to 0. We'll add 1 to both sides to get x equal to 1. So the two x values for our maximum and minimum points are 1 and minus 1 over 3. So we've already been told that 1 is the x value of the minimum point, and so minus a third must be the x value of the maximum point. To find the y value of the maximum point, we're going to sub this value of x equals a third into our original function. And so the y value for an x value of minus 1 over 3 is 6 and 5/27. And that's the maximum turning point of this curve. The C part of the question tells us that the lines K and L are tangents to the curve and L is parallel to K. So we can see K and L here, and they both touch the curve in one place, and both these lines are parallel. Now we know that if these two lines are parallel, they have the same slope. So we're going to find the slope of line K, and we're going to let that equal to the derivative of the function, which is a representation of the slope of the function, to find the other x value that gives that same slope. So when a line is in the format ax plus by plus c, as this one is, we can read the slope as minus the x value over the y value. So the slope of the line K is minus 4 over minus 1, which is equal to 4. So line K has a slope of 4. But we also know that because L is parallel, L has a slope of 4. To find the two x values of the coordinates of the points where the tangents have a slope of 4, we take the derivative, the rate of change or the slope of the function, and we let it equal to the slope 4. So if we subtract 4 from both sides, we have 3x squared minus 2x minus 5 is equal to 0. We're going to factorize to solve this quadratic, so we have 3x minus 5 on x plus 1. To check the factorization, 3x by x is 3x squared, minus 5 by 1 is minus 5, and the sum of minus 5x plus 3x is minus 2x. So we let each bracket equal 0, 3x minus 5 equals 0, and x plus 1 equals 0. On the left hand side, 3x minus 5 equals 0, we're going to add 5 to both sides to give 3x equals 5. And we're going to divide both sides by 3 to give x is equal to 5 over 3. On the right hand side, x plus 1 is equal to 0. We'll subtract 1 from both sides to give x is equal to minus 1. So the point of tangency for line L and the function f is when x is equal to 5 over 3. And the point of tangency for line K and the curve f is when x is equal to minus 1. We were asked to find the x coordinate of the point at which L is the tangent, and so x is equal to 5 over 3.